This is AP Calculus Worksheet 7-5 Solutions. So we have a bug traveling on a vertical wire, so up and down, and it's asking, is the bug speed increasing at time equals 1? Well, at time equals 1, it's at right about there. So we need to analyze this graph. Remember that this is a graph of velocity. That means if I'm looking for velocity, any velocity, that's going to be a height. And if I am looking for anything with acceleration, that's going to be the derivative of velocity. Derivative of height is slope. So I need to look at both the velocity and acceleration to see what's happening with the speed. So I need to look at the velocity at 1, and I need to look at the acceleration at 1. So the velocity at 1 is the height. Height is positive, greater than 0. The acceleration is it's a slope. The slope is also positive. That's going to be greater than 0. And because both of these have the same sign, so same sign, that implies that it is increasing in speed. So this is increasing in speed. And then our conclusion is going to be yes, because it's asking, is the bug speed increasing? And the answer is, it is increasing. All right, so is it increasing at 7.5? So again, we're doing the same thing. We need to do the velocity at 7.5, and we need to look at the acceleration at 7.5. So at 7.5, that's right here. So I'm looking at this point right here. So the velocity, the height is, sorry, it's not greater than 0. The height is negative. It is less than 0. The slope, however, is greater than 0. So these are different signs. So these are different signs. And that implies that it is decreasing speed. So decreasing speed. So the answer is no. It was asking, is the bug's speed increasing? And no, it is not. And now we're looking for the total distance that the bug travels. So total distance is very similar to position change, but we're doing absolute value. It's going to be the integral between 0 and 8, because those are our bounds from 0 to 8. And it is velocity of time, but we don't want to go backwards when this is a negative, so we're going to take the absolute value of absolute value of velocity, and that's going to be dt. So what I'm really doing is I'm looking for the area underneath the curve, or between the curve and the x-axis. So all of this, we have a 2 by 3, 6. Half of 6 is 3. This is a 2 by 3, which is 6. This is a 2 by 3, which is 6. Half of that is 3. And this is a 2 by 1, which is 2. Half of 2 is 1. So this is going to be, and this would be a negative 1, but we're going to take the absolute value of it, so it's going to be a positive 1. That's going to be 3 plus 6 plus 3 plus 1. And that's going to be equal to 13. And that was problem number 1. Let's go to problem number 2. So for problem number 2, you're going to have to use a calculator, and we have this function, and it's asking, is it speeding up? So again, we have to compare velocity and acceleration. So let's go to our calculator. So we go to our y equals function, if the calculator would turn on. So our y equals button, let's clear these functions out. And our y equals function is going to be natural log of x squared minus 3x plus 3. Cool, and then we're going between 0 and 5, so my window, I'm actually going to go from -1 to 6. I think I just want to see more of the graph, and then zoom 0 so that everything scales to fit. And we just need to look at what's happening on the graph. We need to, instead of having the graph being given to us, we're looking at our graph on our calculator now. So at t equals 0.5, so instead of using graph, I'm going to hit trace, and I can move left and right, but to just skip to x equals 0.5, I enter 0.5 and hit enter. And it says, okay, that is where x equals 0.5, or in this case t equals 0.5. And we can see on this graph we clearly have that the velocity at 0.5, velocity at 0.5 is greater than 0, the height is greater than 0, and the acceleration at 0.5, the slope is negative. So when these have opposite signs, so these are different signs, that implies that you are decreasing speed. and therefore it's asking, is it speeding up? And the answer is no, it is not speeding up. All right, is the particle slowing down at time equals 1.2? So again, come to calculator, 1.2, hit enter, and that's on that bottom part of the graph. We can see that our velocity at 1.2, whoa, what's going on here? 1.2, that's going to be less than 0, and our acceleration at 1.2. So the height is less than 0, but the slope is also less than 0. So these are both the same sign, so same sign, and that implies increasing speed. Increasing speed. And it's asking, is it slowing down? No, it's the opposite, so no, it is not. It is speeding up, just in the negative direction. What is the total distance traveled? So total distance traveled, we need to take the absolute value. That's going to be the integral between 0 and 5 of velocity, vt, and then dt, but we need to take the absolute value. So there's the absolute value, and now we need to figure out a way to put that on our calculator. So the quickest way is to, let's get out of that, is to do the function. So we need to say, do the integral. So the integral will be math 9, integral, and then absolute value. We haven't seen that before, but that's going to be math, and then I go right, and ABS, that stands for absolute value, hit enter. Absolute value of VT, and that function is stored in Y1. Again, that's in Y1. So to access Y1, we hit vars, right, enter, enter. That's Y1. End the parenthesis for the absolute value. Then we're going to do comma. So we're taking the integral with respect to this variable, and then here are the bounds. The bounds are from 0 to 5. And then I don't have to end parentheses, but I'm going to. This will take a while to do. So as it's doing that, I'm going to go ahead and write equals and wait for this to calculate. You can see on the top right, this little scrolling bar means that it's working. And there it is. Okay, 5.112. So 5.112. And if you want to do this with the graph, because we do have the graph of this, to integrate and make this a positive, because right now it would be taken away, there is a way to do that as well, although it's I think it's a little bit slower, but I'll show you just in case. So the way that you do that is you go to Y1. First of all, we're going to go left, hover over the equal sign, and hit enter so that it's not selected. It won't graph this now. What we want to do is say take the absolute value of Y1. So again, we go to math, right, enter. Absolute value of Y1, again, Y1 is vars, right, enter, enter. And we want to graph that, so we don't have to rescale it or anything. So now it'll bounce up, so everything is positive now. And now if we go ahead and do the second trace and go to the integral 7 between 0 and 5, it'll take about the same amount of time, but it will also give us the same answer. So that's the other way to do it. And I'll cut the video so you can see what this eventually is. Or not, so it actually maybe went a little bit faster, I'm not sure. But yeah, 5.112. Slightly different, I guess, but it did get it to 3 decimal places. All right, so this is going to be number 3. Is the squirrel speed increasing at time equals 4? So we need the velocity at 4, and we need the acceleration at 4. At 4. And this is the graph of velocity. It says it right there. So velocity at 4, that's going to be this point right here. We can see that the height is obviously greater than 0, and the acceleration is actually it's 0. It's not accelerating at all. So you can't have increasing speed if you don't have any acceleration. So I'm going to say because no acceleration, neither increasing nor decreasing speed. And answer the question, is it increasing? The answer is no, it is not increasing because it is neither increasing nor decreasing. All right, what about at time equals 8? At time equals 8, that's going to be right about here. So the velocity at 8, that is the height. The height is greater than 0. The acceleration at 8, the slope is negative, so it's less than 0. These have opposite signs. Opposite signs always implies decreasing speed. increasing. Okay, come on here. Speed. And it's asking, is it increasing? The answer is no, it is decreasing. And what is the total distance that the squirrel traveled from time equals 0 to 18? So all the way to the very end here, and we just have to calculate all of these areas. So here we go. Split this up really quick into triangles and rectangles, and we have to add up all of these. Remember that this is no longer a negative area, because when we do total distance, whenever you see this is always going to be the integral of between, for the bounds, 0 to 18 of velocity of t, and that's going to be the absolute value of that. Everything's going to be positive dt. So what is that going to be? So we need to calculate these areas. 2 by 20, that's going to be 20, so I'll add the 20 down here. This is going to be 1, 2, 3, 4, 5 by 20, so that's going to be 100. So we're going to do plus 100, and this is the same triangle, so plus 20, plus 20. This is going to be a 1 by 10 divided by 2, so that's going to be a 5. So plus 5. And again, it's positive now, even though it should be negative because we're taking absolute value. So this is going to be 1, 2, 3, 4 by 10. So this is going to be a positive 40. So plus 40. And again, these two triangles are the same as this one. So this is going to be a 5 and another 5. So I can say plus 5 plus another 5. And this is going to be 2 by 10, which is 20. So plus 20. If I add all of those up, what do I get? I get 215. All right, this is going to be number 4. So what is this? How do I interpret this? This is going to be the total distance traveled for the car.
So we're going
car in meters, and that's going to be from time 30 seconds to 60 seconds. And on to number 5, which is basically the same thing. So this is also going to be the total distance traveled. And again, the most important thing is this phrase, total distance traveled of the unicycle. And what are we in? We're in meters, and we're in per second. So in meters from t equals 0 seconds to 60 seconds.